Today we will discuss about, we can talk about law of conservation of energy in a freely falling body. This is most important question for IP pattern. Please listen. 6 marks. Problem adding 2 marks. Totally 8 marks. Okay, let's start. First, we can talk about definition of law of conservation of energy. Definition of law of conservation of energy. Law of conservation of energy is defined as energy neither can be created nor be destroyed. It can be transferred from one form to another form. Suppose, for example, fan is rotating. Let's say electrical energy is converted to mechanical energy. In generator process, mechanical energy, the chemical energy is converted to mechanical energy. Mechanical energy is converted to electrical energy. Electrical energy is converted to light energy. That's a generator. The totally process energy can be transferred from one form to another form, but not change. That's a law of conservation of energy. This time we can discuss about law of conservation of energy in a freely falling body. Suppose if we taken one of the freely falling body. Definition: energy neither can be created. Energy neither can be created nor be destroyed. It can be transferred from. It can be transferred from one form to another form. Energy neither can be created nor be destroyed. It can be transferred from one form to another form. That's a law of conservation of energy. If we take into one freely falling body, suppose this is ground. This is one of the body freely fall at some height. The total height of the body, capital H. Law of conservation of energy in a freely falling body mainly important for two energies process. First one is potential energy and the second one is kinetic energy. Here the potential energy is mainly important for height and the kinetic energy mainly important for velocity. Suppose, for example, potential energy is equal to mgh. Here m means mass, g means acceleration due to gravity, h means height. In freely falling condition of any one object, mainly variable parameter is height h only. M does not change and g is also not changed. Its only change of the parameter is height h. So we can write any one equation of potential energy at some height. Firstly we know about height of the object. And kinetic energy. Suppose, for example, we can write kinetic energy equation 1/2 mv². Here 1/2 means numerical number and m means mass. It's only changing parameter of velocity of object. So we can write kinetic energy equation at any height of the object at some height of the object, firstly we know about velocity of the object at some height. Velocity of the object at some height. So, firstly, the object kept in at some height, the object kept in at some height, this is h, this is h, the potential energy is equal to mgh is formula. Here height means capital H, here small height means capital H. So we can substitute height, potential energy is equal to mgh. Here the object is rest position. The object is having, it doesn't having any motion, that is a rest. So here velocity is equal to 0. Velocity is equal to 0 and also displacement also 0. Displacement also 0. So the kinetic energy equation 1 by 2 mv square. Here v means 0. So kinetic energy also 0. Kinetic energy also 0. The total energy equation, kinetic energy plus potential energy. Here kinetic energy is 0, potential energy is mg capital H. So total energy means mg capital H. Suppose for example the object is freely fall, the object displaced at some distance, in linearly, that is displacement of the object is x. Displacement of the object is x. Here the object is consisting of some height, but from the ground, how much amount of height, that's having, that means h minus x. So the potential energy is mainly depends upon the height of the object. But here the height of the object means h minus x. So h minus x. So potential energy, this is first one. This is second position of the object. Here potential energy is equal to mgh formula. Here h means h minus x. So potential energy is equal to mgh minus mgx. We can write and we know, we can write here kinetic energy of the equation. Here kinetic energy means, the second position of the kinetic energy means, the formula of kinetic energy 1 by 2 mv square. But in free fall condition, according to kinematic third equation, initial speed means 0, final speed v square is equal to 2as. But here a means acceleration due to gravity. The acceleration due to gravity acts in downward direction. So a is equal to plus g, and but here in this process the displacement is considered to the height of the object. Displacement of the object. But the object is initial position here and the final position is there. So the difference between those two positions is x. So displacement of the object means s is equal to x. So v square is equal to 2gx. In this equation, substitution to kinetic energy formula, Ke is equal to 1 by 2 m into 2gx. Here 2 is cancelled, remaining Ke is equal to mgx. In second position of total energy means the total energy is nothing but kinetic energy plus potential energy. So the total energy equation of second position of the object, that is equal to kinetic energy means mgx plus potential energy means mgh and minus mgx. So mgh minus mgx. Here mgx is cancelled. Remaining total energy is equal to mgh. You can see that here the first position of total energy is mgh and the second position of the total energy also mgh. So in those positions energy does not change but transferred. We can find out in third position of the object, in third position of the object of total energy. In this here the object in initial position here and the final position is there. So the difference between those positions of displacement is equal to h and height, and in this here the object of height is 0 because of the object reached to the ground. So in point 3, the total energy means here first we can find out, we can write in potential energy equation mgh, but here h is equal to 0, but here h means 0 because of the object reached to the ground. So height is doesn't consider, height means 0. So potential energy also 0. And we can write kinetic energy equation of third position of the object. The kinetic energy is mainly depends upon the velocity. The velocity equation is inbuilt of displacement, but the third position is there and initial position is there. Those difference between those positions is height h. So, but here the displacement of the object is h. So, kinetic energy is equal to 1 by 2 mv square. So, kinetic energy is equal to 1 by 2 mv square. But here in freely falling condition velocity v square is equal to 2as. But 2 means 2 into a means g, but s in third position of the object means h displacement. So the substitution of this equation in this here, kinetic energy is equal to 1 by 2 m into 2gh. Here 2 also cancelled, remaining ke is equal to mgh. But the third position of the object is consisting of two energies, but potential energy also 0 and the kinetic energy means mgh. The total energy is nothing but those energies are adding, but one is 0 and another one is mgh. So the total energy is equal to mgh. But you can see that the first position of the object means in this here the velocity also 0, so kinetic energy also 0 and displacement also 0, kinetic energy also 0. So but here only one energy is possible, that is potential energy mgh. The total energy also mgh. But the second position of the object, but here those two energies are there. The first one is potential energy. Potential energy is mainly depends upon the height of the object, but here height means height of the object from the ground, but here height means h minus h. So here substitution of h minus h, mgh minus mgh. Here kinetic energy means 1 by 2 mv square. Here free falling condition according to kinematic third equation, v square is equal to 2as, v square is equal to 2gx. Kinetic energy 1 by 2 m into v square means 2gx. Here 2 is cancelled, remaining mgx. The total energy mgx plus mgh minus mgx. Here mgx is cancelled. Total energy means mgh. And third position of the object, the height means 0, potential energy also 0, kinetic energy means 1 by 2 mv square. Already we know that v square is equal to 2gh. H means displacement of initial and final positions. So 2 is cancelled, remaining mgh. Total energy is equal to mgh. In this proof, we must prove that here the energies doesn't change, but that can be transferred one position to another position. Energy does not change at any position, but transferred one position to another. This is mostly important for IP pattern. This is only 6 marks. We got 8 marks. We will got 8 marks already. We know that this question is adding to one small problem. The problem and question we will write now in examination pattern. The problem and question we will got 8 marks only. You will do it only in this answer. You will got only 6 marks. Okay. This is most important for IP pattern. In this lesson number 6, work, energy and power. This is most important for 90% of IP pattern question. The work, energy and power that have 3 important questions, 3 important essay questions. The first one is already we was discussed about in yesterday, but this day yesterday means we was discussed about yesterday, that was discussed about the work energy theorem. But today we can discuss about freely falling water. Please screenshot.